to Know What's Cooking, where we're changing the world one recipe at a time with a splash of physics. To be fair, this episode is going to have no recipe and more than a splash of physics, but it's going to be really short. We measure so many things in the kitchen. We measure volume and weight and temperature. And I think temperature is one of those things that maybe we don't fully understand well enough. And so I'm going to do a quick demonstration to show you what temperature is. What I have here is water that is just boiled, so just a couple degrees below the boiling point. And here I have the same substance, water, but it's been sitting with ice cubes, so pretty much very close to the freezing point. So I'm going to put the near boiling water into the hot jar, and I'm going to put the near freezing water in the cold jar. So what this looks like is two pretty much static glasses of water. From a macroscopic scale, from my eyeballs, I can't really tell the difference other than a little bit of vapor escaping here and a little bit of condensation that's forming in front of the cold bottle. So what we're going to do now is just add a little bit of food coloring to each of these and see what happens. I'm going to add 3 drops to the hot and 3 drops to the cold. And I'm going to put up a little bit of a white backdrop so you can watch this a little bit clearer. So there's a real dramatic difference here in what's happening. Temperature is actually a measure of the average kinetic energy or motion of the molecules. So while they look like they're static and they're just like glasses of water with no motion, we see that the hot jar has a whole bunch of motion, a whole bunch of these water molecules, H2O, that are either moving by translation, maybe they're vibrating, or maybe they're rotating. And so we see in a hot jar, we have all kinds of motion, and so when I put the food coloring in there, it mixes it in really rapidly. The cold jar, in contrast, has those same water molecules, but they're just moving much more slowly. And so even after all this time, we still see that the food coloring is not completely incorporated. See, physics is kind of fun. Hopefully this will lay some foundation so we'll understand a little better when we're talking about temperature in the kitchen, what temperature means. I'll see you next time for a recipe, I promise.